Welcome to my math class. I am Mohammad Ali, mathematics teacher. Today we try to solve some question from Cambridge IGCSE Additional Mathematics Function Chapter, Exercise 1.3. We will solve from question number 17. Question number 17, fx equals to 2x minus 6 for x belongs to real number, gx equals to root over x for x belongs to real number, comma, x greater than equals to 0. Find the domain and range of A, f gx, number B, g fx. So at first we try to do question number 17a. So question number 17, here fx is given 2x minus 6 for x belongs to real number, and gx equals to root over x for x belongs to real number and x greater than equals to 0. So a number f gx, we may find f gx at first. So if gx value is here root over x, we have to put this root over x in f function instead of x. So it will be 2 root over x minus 6. So our f gx equals to 2 root over x minus 6. Now, as we want to find out the domain and range, we have to observe this mapping. So x mapped with gx and gx mapped with f gx. So here in g function, what is the status of x? X belongs to real number and x greater than equals to 0. When we put gx in f function, here x belongs to real number. So we can say that gx we have to put, gx value we have to put in f function. So here x belongs to real number. So gx belongs to real number. So we can able to say here the domain will be x greater than equals to 0 and gx belongs to real number. All real number, but it must be greater than equals to 0. Now, so this is domain x greater than equals to 0 and gx belongs to real number. Now, if we want to find out the range of fgx, we may sketch this curve, sketch this line. Okay, so when we put here x value 0, y value will be minus 6. When we put here x value 4, square root of 4 is 2. 2 2s are 4, minus 6 is minus 2. So when 4, this is minus 2. This is actually curve type, not a straight line. When x value 9, the square root of 9 is 3. 3 2s are 6. When it is 9, it will be 0. So if you observe, we will see that the range is greater than equals to minus 6. So you have to write range f gx belongs to real number and f gx greater than equals to minus 6. So number 17a completed. Find the domain and range of number B, gfx. So we will find out the composite function gfx. We will put fx function in g function. So it will be root over 2x minus 6. So if you observe this mapping, x mapped with fx here. So here the fx function, x belongs to real number and fx mapped to it gfx. So here in g function, x belongs to real number and x greater than equals to 0. So x belongs to real number, and here in g function also x greater than 0. So in f g function, we have to put fx instead of x. So we will write here fx greater than equals to 0. So fx is what? 2x minus 6 greater than equals to 0. From here we get x greater than equals to 3. So we'll write here domain x belongs to real number and x greater than equals to 3. Now if we want to find out the range, if we sketch this curve, sketch this like if we put here x value 3, when we put here x value 3, y gfx is 0, 1, 2, 3, when put x value 3, 0. When you put here like 9 2 z, 9 2 z. So when you put here like 5, x value 5, 2 5s are 10, 10 minus 6 is 4, square root of 4, square root of 4 is 2, so 1, 2. So it will be like this. When you put here like 7, 7 2s are 14, 14 minus 6 is 8. So when you put here 7, when you put here 7, 7 2s are 14 minus 8, so root over 8. Root over 8 is like this. So it will increasing. And here the lowest value is 3. Lowest value y value is 0. So we have to write here range of gfx. Gfx belongs to real number and gfx greater than equals to 0. Number 17 completed. Question number 18. Fx equals to 2x square minus x for x belongs to real number. Gx equals to 1 by x for x belongs to real number. X is not equals to 0. Number A, find the range of fx, Roman 2, gx. Number B, find the domain and range of Roman 1, fgx, Roman 2, gfx. So at first number A, if we want to find out domain range of fx, it will be better to use the completing square. So 2x square minus x. So take common 2. It will be x square minus 1 by 2x. Now this is ready for doing completing the square. So 2 here. It will be x minus b by 2. Half divided by 2 whole square minus half divided by 2 whole square. So it will be 2x minus 1 by 4 whole square minus 1 by 4 whole square. So it will be 2. If you remove the bracket, you will get a 2 into x minus 1 by 4 whole square minus 2 into 1 by 16. So finally we get 2 into x minus 1 by 4 whole square minus 1 by 8. So here the minimum value of this curve is minus 1 by 8. If we sketch this, minus 1 by 8 is the minimum value. And for x equals to 1 by 4, like this is 1 by 4, we get this minimum value. So this curve will be like this. So range fx belongs to real number and fx greater than equals to minus 1 by 8. Okay. Number Roman 2, range of gx. So if we sketch gx, it will be range of gx. If we sketch this curve, it will be in the first quadrant and third quadrant. Here x is not equals to 0. So we have to write here range of gx. Gx belongs to real number and gx is not equals to 0. So number A completed. Find the domain and range of Roman 1 fgx. So at first we have to find out the composite function fgx equals to 2 by x square minus 1 by x. X mapped to gx, gx mapped with f function. Here x belongs to real number and x is not equals to 0, but here x belongs to real number. So you can say that domain of fgx, so x belongs to real number and x is not equals to 0. To find out the range of fgx, we have to use the Desmos curve. Now see how can we find it. Now find out the range of fgx. We have to sketch this curve by Desmos curve. Here we found that the lowest position of this curve is, that means y value is minus 1.25. That means minus 1 by 8. So range of this fgx is fgx belongs to real number and fgx greater than equals to minus 1.8. So we have to sketch this curve by putting the different values of x, then we will get this curve. So range fgx belongs to real number and fgx greater than equals to minus 1 by 8. So Roman 1 completed. Now we have to find out the range and domain and range of gfx. Now composite function gfx is 1 by x into 2x minus 1. If you observe this mapping, x connect with fx, fx connect with g, that means gfx. In f function, the status of x is x belongs to real number. And when fx we put in g function here, x belongs to real number and x is not equals to 0. So we have to write here domain gfx belongs to real number and gfx here gfx belongs to real number, that means x belongs to real number. So the x belongs to real number and x is not equals to 0 and x is not equals to half, because if we put here x equals to 0, it is undefined, and x equals to half, it is also undefined. So x is not 0 and x is not equals to half. And range of gfx. So gfx belongs to real number and it is always be positive. It is always be positive. So gfx greater than 0. Number B, Roman 2 completed. Question number 19. Fx equals to 2x plus 5 for x belongs to real number, comma x less than 2. Gx equals to x minus 3 whole square for x belongs to real number, x greater than 3. Number A, find the range of Roman 1 fx, Roman 2 gx. So at first number A, range of fx. So we may sketch this line. So y-intercept point is positive 5. And when x value 2, y value is 9. Y value is 9. So we have to put all values less than 2. So this line, highest value will be 9. And it should go downside. That means from downside to upper side up to 9. So we have to write the range fx less than 9. So because when x value 2, it is 9, but 9 is not included. That's why we have to write here fx less than 9. Now, number 2, the range of gx. So we have to sketch this curve. It will be 1, 2, 3. So horizontal translation y plus 3, and y-intercept point is 9. So this curve will be like this. Here x greater than 3. When x value 3, y value is what? Y value is 0 here. So we have to put all values greater than 3. So in this side, when you put here 4, it will be 4 minus 1, 4 minus 3, that means 1 square. It will be 1. When you put here 5, 5 minus 3 is 2, 2 square means 4. So range of gx belongs to real number and gx greater than 0. So this is the range of gx. Now, number B, find gfx, composite function. Now find gfx, g here, fx value is 2x plus 5. We have to put this value in g function instead of x. So it will be 2x plus 5 minus 3 whole square. So it will be 2x plus 2 whole square. So this is gfx, this composite function. Now find the domain and range of gfx. Number C, we have to observe this mapping. X mapped with fx, fx mapped with gx. So in f function, x belongs to real number and x less than 2. And gx function, x belongs to real number and x greater than 3. So here, both are real numbers. So fx, here x less than 2 and fx less than 3. The fx less than 3. This is fx. Because why fx less than 3? Because we have to put fx in g function instead of x. So as x greater than 3, we have to write here fx greater than 3. We have to write here fx greater than 3. Now I write this, I write it clearly. So fx greater than 3. So fx is what? 2x plus 5 greater than 3. So 2x greater than 3 minus 5. So x greater than minus 1. So we have to show this in the number line. X greater than minus 1. So minus 1, this is 0. That one is 2. X greater than minus 1, less than 2. So domain will be x greater than minus 1 and less than 2. X belongs to real number. Now we have to find out the range. So it is better if you want to find out the range, you have to sketch this. If we sketch this, what happened? Like if we take 2 outside, it will be 4x plus 1 whole square. So it will be minus 1. And this is 4. This curve will be like this. So we have to put here x value minus 1 to 2. So minus 1 here. If you put here x value minus 2 here, what happened? If you put here x value 2, 2 plus 1 is 3. 3 square means 9. 9 means when 2 plus 1 is 3, 3 square means 9, 4 is 36. When x value 2, y value, that means gfx is 36. So range g f x belongs to real number and g f x greater than 0 but less than 36. Very important here, because we have to put value between -1 to 2. When you put here x value -1, y value 0. So this is the lowest value of this composite function. When you put here x value 2, so g of x is 36. So number 19 completed. Question number 21. Fx equals to 3x plus 2 for x belongs to real number, comma, x greater than 1. Gx equals to x squared plus 1 for x belongs to real number, x greater than plus 8. And number A, find the range of fx. So if we want to find out the range of fx, we have to sketch this line. So here, when x equals to 1, fx means y equals to 3 1s are 3 plus 2 5. That means 5. When x value 2, it will be 3 2s are 6 plus 2 is 8. So 8. So line started from, the lowest value of this line is 5, and started from 5, it is go up upper side infinity. So range of fx, number 1, fx belongs to real number and fx greater than 5. Number 2, so the range of gx, if we sketch this curve gx, it will be this is the lowest value is 1. We have to put here x value greater than 8. So if you put here x value 8, what will be the g8? G8 will be 8 square means 64 plus 1, 65. So the highest value, it will be started from 65. So range of gx belongs to real number and gx greater than 65, because when we have to start it to put x value greater than 8. So when you put here x value 8, g8 equals to 65. So range is greater than 65. Number B, we have to find out gfx. So gfx value is here 3x plus 2. In g function, instead of x, we have to put it. So it will be 3x plus 2 whole square plus 1. If we simplify, we'll get here 9x squared plus 3 to the 6, 12x plus 4 plus 1. So finally, it will be 9x squared plus 12x plus 5. So gfx equals to this. Now we have to find out the domain and range of gfx. So find the domain and range of gfx. At first, we have to observe this mapping. X mapped with fx, fx mapped to g, that means gfx. In f function, the status of x is x belongs to real number, x greater than 1. When you put fx instead of x in g function, here x belongs to real number and x greater than 8. So we have to write here x greater than 1 and x greater than 8 means here fx greater than 8. Fx is 3x plus 2 greater than 8. So 3x greater than 6. So x greater than 2. So if we see this in the number line, this is x equals to 1, x equals to 2, x greater than 1, and x greater than 2. So this part is overlapped. overlap. So domain x belongs to real number and x greater than 2. Now we have to find out the range. If we want to find out the range of g of x, it will be better to sketch this curve. This curve, the lowest value is 1, positive 1. And for x equals to minus 2 by 3, we get the lowest value. So if we sketch this curve, the lowest value is 1. And when x equals to minus 2 by 3, get this lowest value. And here y-intercept point is 5. The curve will be like this. One thing, we will put here in this composite function x greater than 2. So when you put here x value 2, what happened? GF2, it will be 3 into 2 plus 2 whole square plus 1. 3 2s are 6. 6 plus 2 is 8. 8 square means 64 plus 1 is 65. So when you put here x value 2, it will be 65. We have to put all this value greater than 2. So range is GFX belongs to real number and GFX greater than 65. So I think everybody understood all of these maths. So for find out the range, it will be better if you are able to sketch this curve and observe all of these maths properly. I want to give you one homework. Question number 20. Try to do at home and please send it to me. If you have any confusion, I will help you. Thank you everybody for watching. Thank you all. Please subscribe my channel.